Hello, everybody, and welcome to this month's webinar. My name is Michael Kramer. I am presenting to you all today on behalf of Perry Johnson Laboratory Accreditation, and I am the Calibration and Inspection Program Manager at PJLA. Great to have you on with us today, and as you can see from this slide, what we're going to discuss is Section 6.3 on facilities and environmental conditions, along with Section 6.4 on equipment within the ISO IEC 17025 2017 standard. As always, this webinar is being recorded. You can go back to our website and re-listen to this. We also have various past webinars there. Also, you have the capabilities of just extracting the slides. So feel free to go to our website and follow the tabs to webinars. Everybody currently, hopefully everybody can hear me, but I can't hear you. You're muted. You should have a question tab there. So if a question arises during this presentation, feel free to type it in there. Please keep the questions in regards to today's topics. And at the conclusion of the presentation, we will go back and look at my questions that were submitted and try to answer them all. So again, welcome. So we're going to start out looking at Section 6.3, and this is facilities and environmental conditions. So this will be for testing calibrations, whether or not they're performed at your environmentally friendly fixed conditions, or perhaps you're doing test or calibrations outside your permanent control. The standard requires that environmental and facilities conditions related to the requirements be met. If they are not, this would be considered a deviation. We'll discuss that a little bit later, particularly those folks that are going on site. I know I'm a calibration program manager. I know a lot of calibrators perform the services of going on the customer site and performing calibrations there. So looking right at the requirements, pretty self-explanatory here under facilities and environmental conditions. The facilities and environmental conditions shall be suitable for the laboratory activities and shall not adversely affect stability of results. So we have a couple shalls in there. As you know, shalls are requirements. So what are we referring to here? Things that can be looked at. And that's captured in the note in the standards. It could include such things as microbiological contamination, dust, electromagnetic disturbances, radiation, humidity, electrical supply, temperature, sounds, and vibrations. Any adverse effects created by these examples should not impact the test or calibrations that are being done. 632, the requirements for facilities and environmental conditions necessary for the performance of laboratory activities shall be documented. So we have to have this documented somewhere. So what are we referring here? So under the particular test or calibrations, for example, looking at a procedure, if there's any environmental conditions that need to be adhered to, they need to be captured, documented. Typically, it's could be within the actual procedure itself. So, for example, temperature should be within the range of 68 degrees plus or minus 2 degrees. Relative humidity could be greater than 50%. The unit under test in the laboratory shall stabilize for a minimum of 12 hours prior to calibrations to permit thermal stabilization. And if not, calibrations are not to be performed if the environmental conditions are outside the allowable limit stated above. So this is an example of what you should have in place for any particular environmental criteria. Typically, this is temperature, humidity, that would possibly impact and perhaps need to be controlled in order to perform your test or calibrations. 633, the laboratory shall monitor, control, and record environmental conditions in accordance with relevant specifications, methods, or procedures, or where they influence the validity of the results. So perhaps you have temperature range. You may have to capture it real time as you're doing the test or calibration, or perhaps you need to monitor it more thoroughly to assure that the environment was stable prior to when the test or calibration. So in those instances, perhaps a data logger, which is pictured over to the right, to assure that there was no drastic changes in temperature that or humidity, in particular example over there on the right, that could possibly impact the unit under test and impact the test or calibrations that are being performed. Still under facilities and environmental conditions, measures to control facilities shall be implemented, monitored, and periodically reviewed, and shall include but not limited to access to and use of areas affecting laboratory activities, prevention of contamination, interference, or adverse influences on laboratory activities, effective separation between areas with incompatible laboratory activities. So the areas where these test or calibrations are being performed should be controlled. I always say that the UPS man can't come freely walking in a calibration lab and open the doors and without having some sort of controlled access. It should be effective separation. Perhaps you're doing precision weighing, you have microbalances. That should be away from any area that perhaps is producing vibration, perhaps any sort of loading dock or high traffic area. So 635, these are for on-site calibrations. When the laboratory performs laboratory activities at sites or facilities outside its permanent control, it shall ensure that the requirements related to facilities and environmental conditions of this document are met. So this is particularly aimed at on-site calibrations. Or test. Calibrations or tests I see quite often with calibration facilities where they may be going into the customer site, which may not be environmentally friendly as the confines of the fixed laboratory facilities. So what if the environmentals are outside specified conditions? Let's say that you were operating between the 68 plus or minus 2 degrees, and it happens to be 80 degrees. What can you do? You're going to perform the calibration on site at the customer location, and it's outside the specifications. This is actually covered under 743, handling of test and calibration items. So that's a requirement that I'm bringing forth here. The laboratory shall consult the customer for further instructions before proceeding, and shall record, i.e. make a record, record the results of this consultation. When the customer requires the item to be tested or calibrated, acknowledging a deviation from specified condition, the laboratory shall include a disclaimer on the report indicating which may be affected by the deviation. So hence, as you can see here, our discussion needs to be held with the customer. Customer has to agree to proceed, even though you are out of your specified environmental criteria. And this is also captured in 7.8. That deviation also would need to be put on the report of test or calibration that you provide that customer. All right, so we're going to switch gears here. That's section 363, facilities and environmentals. We're going to look at the requirements now on equipment which is section 6.4. Some of the highlights that were brought forth when the standard was revised in 2017 is a lot of emphasis on reference material, reagent, and software. They are also considered as equipment. Conditions to calibrate equipment are set. So specifically, if the accuracy or uncertainty affects the validity of results, and if you need to obtain metrological traceability. References to 17034 is included to emphasize the competence of reference material producers. Okay, looking at these requirements. 641, the laboratory shall have access to equipment, including but not limited to measuring equipment, software, measurement standard, reference material, reference data, reagents, consumables, or auxiliary apparatus. This is required. That is required for the correct performance of the laboratory activities, and it can influence the results. Hence, you have to have the tools, the right tools to do the job, basically. So you have to have access and be able to utilize the equipment for the correct performances of the test or calibrations that you are performing. Pretty straightforward there. So basically, use the right tools for the right job. Mention reference material. There's a lot of notes in the standard here. So 17034, that is the accreditation standard for reference materials. So as far as looking for competencies of reference materials producers, 17034 accredited sources would be a desirable organization to pursue. I know reference materials are utilized a lot in testing. So if you're not familiar with what a reference material is, I got this definition here. Basically, reference material is a substance with a specific defined characteristics that serve as a comparative values for analysis. For example, for microtoxin analysis, reference materials would be contaminated corn or wheat samples with a clearly defined microtoxin concentration. Folks that are doing calibration, I see reference materials utilized a lot for pH and conductivity, those solutions that has a known content in it, usually like 7.0 pH, already been produced by, ideally a 17034 reference material producer would be other examples of reference materials. When the laboratory uses equipment outside its permanent control, it shall ensure that the requirement for equipment of this document are met. So we're referring to, mainly traceability here. So if for whatever reason your equipment goes out of your control, or you need to acquire equipment that you don't own, and it's out of your control, and traceability is needed, you need to assure that those requirements are met. If you have equipment that goes out of your control, it's a good idea, as you'll see, to have intermediate checks in place where you can check it when it goes out, you can check it when it comes back. I hear often folks say, well, it always stays in our control. Just playing devil's advocate here. Those of you that sends equipment off, perhaps to be calibrated. If you think about it, that the equipment is shipped to the calibration facility. They do the calibration, provides you a nice report, and then it's shipped back. So in the interim there, technically it's out of your control. So it's a good idea too, like I said, prior to shipping out, have an intermediate check. Just check it when it goes out, check it when it comes back, see if there's any deviation there. That it could be detected. 643, the laboratory shall have a procedure for handling, transport, storage, use, and planned maintenance of equipment in order to assure proper function and to prevent contamination or deterioration. So often if your equipment is pretty stable as far as where it's placed, it's not moved, transported a whole lot, say often can be referred in manufacturer protocol as far as handling and transport if need be. I think this is particularly important for the folks that are going on site, where you are constantly taking equipment, packing it up, moving it from location to location. Would like to see, as required, a procedure for the handling, transport, and storage of this equipment, particularly in the cases where it is being moved around frequently, perhaps to perform on-site calibrations or tests. Okay, moving on. The laboratory shall verify that equipment conforms to specified requirements before being placed or returned into service. So again, if you have a system of intermediate checks, control charts, or perhaps equipment's being used in testing, where you incorporate perhaps controlled samples, spikes, blanks into the process before, for whatever reason, before you place a piece of equipment into service, or returning to service, perhaps it went down, had to be repaired. You have to assure that it conforms to specified requirements. Of course, you might think, and you'll see here in a little bit, calibration. So, of course, you send equipment into facilities to have it calibrated before you put it into service. Well, that's going to be captured here soon, as far as when you have to calibrate as opposed to verification of equipment. Okay, 645. The equipment used for measurement shall be capable of achieving the measurement accuracy and or measurement uncertainty required to provide a valid result. So perhaps you have specified that your temperature device, your temperature measuring device is required to have an accuracy to be within 0.5 degrees C. What I'm trying to picture here is the device over there on the left, probably would not fit that bill. And I have a sample of a scope of accreditation. So if you knew you needed that accuracy, if you look on a calibrator scope of accreditation, that's the CMC, calibration and measurement capabilities. That's the best uncertainty you're going to be able to get from that provider. So in this case here, I have a CMC of 0.66 for equipment to measure temperature. So the uncertainty is going to be higher than 0.5. That facility should not report an uncertainty less than what's on the scope of accreditation. So calibrate it. So you have equipment. When does it need to be calibrated? Well, measure, and this is captured in 646. Measure equipment shall be calibrated when the measurement accuracy or measurement uncertainty affects the validity of the reported results, and or calibration of equipment is required to establish the metrological traceability on the reported results. So if traceability is needed, of course, you'll have to have the equipment calibrated and assure that it's meeting the requirements and, PJLA's policies if you're accredited with us in PL number 2, and also the section on traceability in 17025. So notes here, notes in the standards, additional information. Types of equipment this would include would be those that are used direct measurement, for example, use of a balance to perform a mass measurement. Those that are used to make correction to the measured value, perhaps temperature measurements. You have to capture temperature, like for pipettes, for example, you corrected Z60 correction, corrected temperature to 60 degrees, where you have to take the temperature and measure the temperature and utilize the differences when you're making that calculation. And those used to obtain measurement results calculated from multiple quantities. This could be for air buoyancy corrections, for example, where you're taking temperature, humidity, and barometric pressure to figure the air buoyant effect that's being placed on the unit under test. So you have equipment, you have a calibrated course, say you need to have metrological traceability. Calibration is not a one-time thing. So you have to establish calibration programs, which shall be reviewed and adjusted as necessary in order to maintain confidence in the status of calibration. So have to establish calibration intervals. That is the decision that's going to be up to the organization. Some things you might want to consider would be the manufacturer recommendations. You can also look at risk. So one thing under non-conforming calibration or testing, when you send instruments to for calibration and they're out of tolerance, then you might have to implement non-conforming calibration and testing work. So, for example, if you just blanketly put a 5-year interval on the program, you could possibly have to go back and do an impact analysis covering 5 years. It should be reviewed and adjusted. So let's say you blanketly conservatively looked at the risk and state, hey, we'll send it out once a year. So you do that perhaps every year that the equipment is rock solid, it's being handled appropriately, it's not drifting, may permit, excuse me, an increase in the calibration interval, or perhaps it's creeping up toward becoming out of tolerance where you may want to adjust it and shortening it. So again, as per 647, calibration programs need to be established. Excuse me, all equipment requiring calibrations or which has a defined period of validity shall be labeled, coded, or otherwise identified to allow the user of the equipment to readily identify the status of the calibration or period of validity. So based on that calibration program, that calibration interval you put on the device, you should be able to associate that with the device when it's being used. Ideally, a label. That's probably where I see it most. It would be, of course, readily available. It's right in your hand. So if you have a calibration label right on there, it's not required though. It's just got to be readily available. So perhaps it could be at the technician's fingertips, as far as perhaps having a spreadsheet on the software on the computer, and it can pull that information up rather quickly. As an assessor, this is something, hey, if this label's on there, it's going to meet the bill. If I ask someone to, hey, when does this pipette, for example, need calibration, and I don't get that answer until, several hours later, then I would consider that as not being readily available. Okay, 649 has to do with defective equipment, which perhaps has been subjected to overloading or mishandling, give questionable results, or has been shown to be defective or outside specified requirements, shall be taken out of service. It shall be isolated to prevent its use, or clearly labeled or marked as being out of service until it has been verified correctly. The laboratory shall examine the effect of the defect or deviations from specified requirements and shall initiate the management of non-controlling work procedure, which is 710. So in other words, if the equipment was malfunctioning and it was actually used to perform tester calibrations, then you'd have to do that impact analysis, and worst case scenario, recall some tester calibrations that were performed. So again, if equipment is out of service, it's got it. Ideally, you're going to remove it. You're going to label it. It's sort of depicted there in the illustration there, where it can accidentally be used to perform tester calibrations. When intermediate checks are necessary to maintain confidence in the performance of equipment, these checks shall be carried out according to a procedure. We mentioned often with have over there like blanks control charts. Often it's built could be built right into the testing protocol, where you're checking the testing perhaps with a sample. Over on the right there, perhaps weekly, daily checks of your analytical balances with test weights would be an example of an intermediate checks. Those folks moving balances around or perhaps taking them on site at the customer location, that is something that should be done prior to performing the test or calibration. 6411 has to do with correction factors. When calibration and reference material data include reference values or correction factors, the laboratory shall ensure the reference values and correction values are updated and implemented as appropriate to meet the specified requirements. So what are we referring to here? Correction factors. So typically when you send an instrument in to be calibrated, let's say these units were in degrees Fahrenheit, and it may not be exactly, in most of the cases, or not exactly what the nominal amount states, and you typically would have a correction associated with it. So, for example, if the 110 degrees and you had a correction of -3, that would mean that the true temperature is 0.3 degrees less than what is actual reading. So if you need to incorporate those correction factors into your testing or calibration, then that would be carried forward into the testing and calibration protocol. When you use that device, you also take into account if it's applicable, the correction factor. Often if the device is within tolerance and it's determined, hey, it's not going to affect anything, just as long as it's within that tolerance, it may not be necessary to carry the correction factors forward. The laboratory shall take practical measures to prevent unintended adjustments of equipment from invalidating results. So you have equipment that was sent out, your technicians are using it. You want to make sure that nothing's being done that could affect the integrity of the traceable calibration. So typically what I have depicted there, more mechanical over there, a lead wire seal could be sealed with the adjustment element sealed, and the only way to get into that is to break that seal. Over there with pipettes, a lot, some of them have adjustments where you have a special tool you can go in and adjust it. You want to make sure that's covered, perhaps with a sticker sealed somehow, where if it's removed, again, the integrity of the calibration could be called into question. A lot with electronics sort of things, that's depicted down there at the bottom if they're using your test or calibrations. Often they're protected through some specific mode. You have to have a calibration mode to go into. You have to know what the codes are in order to adjust the device. Records. So your equipment, you have to maintain records, which can be influence the laboratory activities. These records shall include the following where applicable. So it may not be applicable in all cases. So got to capture the identity of the equipment, including software and firmware versions, the manufacturer's name, type, serial number, evidence of verification that equipment conforms with specified requirements, the current location. That may be applicable, may not. If you only have one piece of equipment and never moves, you have one location, it's not really applicable. If you have several technicians that they're assigned various equipments, or you have different locations, then it may very well be applicable. Calibration dates, results, adjustments, acceptance criteria, and due dates for the next calibration. documentation of reference material, results, acceptance criteria, relevant dates, and the period of validity, the maintenance plan and maintenance carried out to date where relevant to the performance of the equipment, and details of any damage, malfunction, modification to, and or repairs of the equipment. Wherever these are applicable, you need to make sure that you have a record. This will bring us to the conclusion of today's presentation. Bear with me for one moment. I'll see what questions I have. All right, starting to populate now. All right, question number 4, or excuse me, question number 1. Clause 645 implies calibration is required for measurement equipment. Equipment by implementation. Non-measurement equipment is optional. Is this the interpretation correct? I never really bear with me. 646, and it specifically says measuring equipment. So I would say for whatever reason, if the equipment is not being used to measure a quantity, then it's your own discretion there as far as 646, or perhaps your testing protocol or calibration protocol may address it separately within the specification of that unit. What factors should be included for environmental conditions monitoring, if any references for water lab, food lab, micro, and calibration? Again, I am a calibrator. I'm not versed in food testing or the water lab. I'm sure, there was things mentioned other than just environmental things. Environmental temperature, humidity, barometric pressure are typically the 3 things I would see with calibrations. I know some folks have things in there as far as light intensity. Again, this is going to be basically geared toward a specific test or calibration. That should be defined up front. As far as calibration, typically temperature, humidity, barometric pressure could all affect calibrations. Other things, such as vibrations, for example, you want to use discretion and evaluate those conditions if they can possibly affect the test or calibrations that are being done. Okay, I got a couple people here saying they lost the sound. So hopefully that didn't affect everybody. Where did the criteria for temperature and humidity come from? It comes from, actually, it will come directly from the requirements that's stated in 632, the requirements for facilities and environmental conditions necessary for the performance of the laboratory activities shall be documented. So I sort of pointed toward the procedure. So wherever that is captured is where it's going to come from. If equipment is broken, what is the best way to handle the analysis, non-conforming of test impact for previous work completed for this equipment? Well, again, intermediate checks I think are very important for equipment. So if it's broken and you felt that it was used to perform test or calibration on customers' equipment while was not operating within specified limits of acceptance, then I would say you'd have to go back to the last time it was checked and you knew that it was operating within the expected specifications of the equipment. If there was any sort of, if it just died in the water, just quit working all at once, and when then perhaps you could put a bookmark in there. So it just depends on your intermediate checks. So I would say just as far back as you determine, hey, it was operating and was within correct specifications. So ideally you had intermediate checks in place. I always say when you send equipment out, it comes back, let's say it was significantly out of tolerance. When did it go out of tolerance? If you don't have any intermediate checks in place, then it could have gone out of tolerance the day after you got it back or the day before you sent it. So I would say that a good system of intermediate checks, and the last time it was shown to be within specified criteria. All right, hopefully everybody heard me throughout. I had a couple things here saying they lost the sound. Before we move on, very good questions. Hopefully I answered them sufficiently. But before I go, just want to announce next month's monthly webinar, which is going to be scheduled for October 28th, which is a Friday. And we're going to look at section 8.9, management reviews, the requirements and the utilization. So look forward to having everybody logged in with us for the October webinar. Thank you and enjoy the rest of your day.